advanced Python programming. We are using the Python 3.14 and without GIL. So the advanced Python programming for image processing, we discuss about some profiling, benchmarking, and how you find the bottleneck of your program and how you optimize it. We talked about caching, we talked about optimization in computer vision. Now I'm talking about the multi-threading and multi-core programming on the Python. In Python 3.14, if you install without global interpreter log, you can use multi-threading in your program. So if you have a conda, you can create environment and activate, and by print out system you can see if false, which means no GIL, and you can use multi-threading. So the previous program that we test is Fibonacci, and now we optimize it for the multi-threading. First, you can see my CPU history here. At first I start with the CPU, then I start with multi-threading. So when I start with the multi-threading, you see all the P cores peak high. Otherwise, just some of them peak and run faster. In single thread is running now. It takes more time compared to the multi-threading, and here you can see just simple Fibonacci and 300,000. So it takes, for example, 50-second time for single threading, but a few seconds for multi-threading process. As you can see, not much change, just because it's used only one thread here. And here the program for multi-threading, also this one, start and join, and then we compare the time for both. Compare for this one and compare for the multi-threading. Still single process is working. There is no peak in the P performance score. This is Intel. This is Apple Silicon. Oh, you can see here all the cores simultaneously work, so it's very fast. 70 seconds just for single core, but when we use multi-core it's 40 seconds. Thank you.